Hi, I'm Clive Watts. I want to talk to you today about IP protection through the volume curve. I'm the Director of Product Marketing at Secure Thingz, and the key message I want to get over you today is to think about planning how to protect your valuable IP. So the agenda that we had today, first of all, was to consider why we want to protect valuable intellectual property or IP along the supply chain, some of the difficulties that exist, even from the development lab stage all the way through to mass production and right out into product retirement, and to consider what kind of strategy we could implement that would actually protect intellectual property at all points in the life cycle and to make sure that that intellectual property is protected at every stage, and an idea of how we can achieve this. So first of all, let's have a look at some of the security challenges that we're trying to address and hopefully resolve through the volume curve. So transferring technology from the design house to production seems like an easy thing, tempting to think that it's very straightforward. So on the left here, we have our OEM designers. At one point, they'll get done with their development, and then there'll be deliverables out of the engineering team, and we can just transfer those over to production, load them up on a machine, and get started, right? Well, actually, it's not that straightforward, as I'm sure many of you realize. What we have actually is a continuum of production volume. We start out with low levels of production, and over time we crank that up until we get to really high levels of production, hopefully in the hundreds of thousands for your product when it's successful and everybody wants one for Christmas. So how does the volume curve look? This is a really important aspect of my presentation today, to really consider the various stages that you'll go through in your product development. Thinking about this knob on the left here, where we're going from low production volume through to high production volume. So it all starts out with the very first prototype of the end product. Here we have the first board, the first one that ever got working, the first one that comes to life with its blinky LED. So everything starts here. And then once that's good, we're probably going to make a very limited number of boards that go out to the engineers. Typically, these will be built perhaps in-house or by a very friendly local contractor who can turn these around in short time. And then as things proceed and everything's going well on the project, we might make another batch of prototypes. So perhaps some of these are going out for demos, a couple of them go out to field applications engineers, that kind of thing. We start to spread them around a little bit more. And then the big day comes where we first start production. So this will be with a contractor typically, and they may make some first articles for us to test, perhaps 50 pieces here, so that we can actually get those back in-house and to make sure that production is going to be good. And then, of course, we finally hit the mass volume production. And here we have that external contractor who may be geographically separated from us with volume production machines. And here we're typically talking about programming up chips that are then mounted on boards afterwards as part of the manufacturing process. At every stage here, there are risks. There are risks of our intellectual property being stolen. So at each stage here, we have people along the path. And people are fallible. People can be persuaded to be bad actors, either to steal intellectual property, which can be extremely valuable these days, or perhaps to interject malware into a product that allows it to operate in some unwanted function in the field, perhaps with a backdoor or a time bomb or something like that. So we have to protect from day one, even that very first prototype, and at every stage through to volume production. So even just considering design here, we have a lot of different roles, we have a lot of different actors at play here. So typically we'll have some software developers, like this guy on the left-hand side, who may be today working from home, I took this photo from one of the stock libraries, and apparently this guy is working from home somewhere on the Adriatic coast. And you can see he's sat at the bar there, not really in a very protected environment. We have hardware engineers too. They're obviously bringing together the hardware elements. And of course, all important is that integration stage and final test, where everything comes together to make the complete product. And of course, at each one of these people are again fallible, whether through deliberate action or through some kind of error or ignorance. There's possibilities for attack, possibilities for intellectual property theft, possibilities for the injection of malware. So what we need here to improve the transfer to production is something like a trusted production planner role. Typically, this would be a person or a role that already exists within an organization. Sure, someone is going to be today scheduling production with outside contractors, but we need someone who's going to consider how to do that securely, to securely connect with production. And really what we need is some kind of tunnel between that person and the production facility. With a tunnel like this going straight from the OEM through to the production facility, then we can aim at keeping out the bad actors. So here he is on the left-hand side, unable to get into this tunnel, unable to access anything that goes through that tunnel. We can think of this a little bit like a VPN. Hopefully most of us attending today are familiar with VPNs. We use them from our home computers or our home offices to connect through to our business servers. And exactly the same intent is there, is to protect the transfer of information from ourselves at our desk at home through to those central servers. We need the same thing here. We need a kind of production VPN to get product from the OEM through to the shop floor. In fact, if we think about this, just tunneling through to the outside of the production facility probably isn't enough. Production facilities are usually a subcontractor, and although we try and audit them and test them, they are a possible attack surface. Who knows what other manufacturing plant is there, what other products are being produced there, who the management team are, who the shop floor team are. So actually it would be quite sensible to see if we can VPN directly into an individual production machine so that we know exactly where our product is going to be made, and we can limit the attack surface to just that one production machine. In fact, in reality, it's unlikely to be a single production machine that's used. For high volume products, we're talking about multiple machines on a shop floor, perhaps to provide some redundancy, or hopefully, in the case of your product, just to get some significant volume through there, so everything's out there in the shops ready for Christmas. So it'd be sensible to see if we can target our VPN to a production group rather than a single machine. So how can we achieve this security? Let's think about a method for actually achieving this tunneling, this VPN through to a single production machine or perhaps a group of machines. And how do we follow the volume curve all the way through from that first prototype through to high volume manufacturing? So what we need as our proposition today is that we need some kind of a vault at the center of the picture on the left here, where we can actually keep everything that is valuable to us. So this would be where all of our important technology is kept. So if we have a vault, then we need some keys for that vault. We need to be able to generate keys for that vault, and we need to be able to hold those keys securely. We need to be able to store those keys somewhere safe. And in order to do our transfer to production, we need to be able to encrypt things, and we need to be able to decrypt them at the other end so that they can be used on the final product during manufacture. And very importantly, we need to be able to create an identity for that individual product. Many of you, I'm sure, are aware of the guidelines that are out there in various countries on IoT, consumer and industrial products. And creating a unique identity for a product features very, very highly on the list of recommendations, or in fact the legal requirements for IoT-based products today. And so we need to be able to create an individualized identity for each product as it goes through manufacture. Not a group identity for a batch of products, but an individual product for each one. And to go with that, we need to be able to create a certificate that encapsulates that identity. So when this device connects onto a network, for the first time it goes into service perhaps, then we can actually identify ourselves to that network and carry out a process of attestation whereby we validate each end and then can be sure that the conversation that ensues from that connection is a good one and can carry as little risk as possible. So what we really need here is some kind of specialized hardware security module. Many of you may be familiar with HSMs that are used in the financial markets, or perhaps for storing valuable documents within a business. But these are not suited, though, to this particular environment. And what we need is something that is very orientated towards this development environment and production environment. We need an essential core technology that allows us to carry out all these activities. So what we really need is a specialized hardware security module dedicated to development and manufacture. And you may ask why we couldn't use a commercial HSM, just go out and buy one. Well, part of the problem in this environment is this HSM needs to operate standalone. By that, I mean it needs to operate off network. So most of you will be familiar with the production environment and know that although machines on the shop floor are networked together, they are very, very rarely networked to the outside world. So we can't rely on anything in the outside world actually being able to be accessed. So we can't use remote servers for this process. We can't use a cloud server or some kind of dedicated server on a network. Everything has to be internal. And of course, like a commercial HSM, we need something that is secure by design. So something that is going to hold our vault contents securely. For example, tamper-proofing, so that we can detect if someone attempts to access the secrets that are held within inside this device, and to be able to zero those valuable items, so that if someone gets inside, for example, decapping a chip, there is nothing there for them to see. So secure design is also a very important aspect of this specialized hardware security module. Let's take a look at how this would work in practice. So here again, we have the production planner on the left-hand side, and her responsibility really would be to work with the engineering team to collect together all the deliverables that need to go out to the production floor. So this example would be obviously the application that the end customer uses. A secure boot manager. This is a very critical part of protecting products today, outside the scope of this talk, but I'm sure most of you are familiar with the need for a secure boot on a product to protect secrets and applications. We may have some configuration data that needs to go in there for the particular product, and other forms of data such as databases that are referred to, perhaps a list of servers that need to go into the end product. So the production planner here will pull together all that information and will save it securely inside the HSM. Once that's done, then we can produce a production package that can actually be taken out to the shop floor at the production company. And this is an encrypted package and an encrypted transfer. So the transfer itself could be done by email, could be done by FTP, anything like that, because we're not concerned about security of that information as it's already been protected. And then that production package is then stored on a matching hardware security module inside the production machine. So you can see here there's a direct relationship between an HSM at the OEM and an HSM at the production facility. And in fact, these two are linked together by their identities, so that that production package can only be targeted at one machine and can only be consumed by one machine at the end of the line there. Let's think for a moment a little bit about the desktop environment now, because we have the same challenges as highlighted earlier on. We have actors and we have an environment which we can't necessarily control. So we need to think about the prototyping and development environment as well. So during the development process, we have the same deliverables essentially being produced, an end application, a secure boot manager, some configuration data, perhaps other data that's needed at runtime. And in this scenario, we can save all that information inside a hardware security module. Again, doesn't need to be on the Office network, so that that's protected from external access. And we can then, in exactly the same way, we can produce an encrypted production package out of that system and transfer that to production. But in this case, production is actually a desktop environment. And you can see a typical setup here at the top right-hand side, where we've got a desktop PC or laptop connected to this specialized HSM. We would call it a desktop provisioner. And connected to that is one of the prototype boards that we wish to program up or provision with all of this information together on it. Again, this is an encrypted transfer, so there's no risk of those protected intellectual property items being stolen or malware being injected. And you can see the parallel with the production environment here, in that the process and the steps here are very similar. The level of protection is the same, and we can, on a desktop, simulate exactly what's going to happen on the shop floor so that we can be certain to know what that process is and to be certain that we know it's secure and trusted. If we look at what's going down in the production machine itself now, after that transfer has taken place, we consider the two different use cases: one, volume provisioning that we looked at a couple of slides ago, and number two, the desktop provisioning that we looked at on the previous slide. These are essentially the same process. What we have is all that intellectual property stored inside this specialized HSM. And what we're going to do at the point of production on each individual device that's being programmed, typically a microcontroller, is to actually transfer, to unencrypt that information that's been delivered and to transfer it into the device itself. Typically, this would be on-chip memory inside the device, perhaps on-chip flash for permanent storage. And we would then, during that process, want to secure that information inside the chip. So the identity that's being created for that chip, the keys that allow the device to do secure communications, and the secure boot manager, all themselves need to be securely stored to be protected within that microcontroller itself. And if we have enough capability within that device, we can actually maintain a stream of encrypted information all the way through to the core of that device and only decrypt that information when it's actually inside the chip, so further reducing the attack surface. Let's just think a little bit more about the other end of the process here for a moment, where we've got this development team. Software engineers, hardware engineers, test and integration. We can actually provide an HSM, this specialized HM, to each one of those individuals so that they can hold their information securely. So when they go home at night, it's all held within the vault inside the HSM. And so that individuals who should not have access to that cannot see that information, they cannot steal intellectual property, They cannot introduce malware. And what we should do then at the final point where we want to go to production is to actually change out the keys that are securing that development environment with alternate keys which are going to be used for the production environment. And this is important because then the information cannot be reopened, it cannot be decrypted by anyone in that development team after we've gone to production. Sure, we can repeat this process later on if we need to make changes, but at the point we go to production, that information is secure, and the production planner is the only one who has the keys to the production keys to that package. So to conclude, I want to make sure you leave thinking about the whole supply chain here, thinking about your volume ramp. The supply chains for products today are very complex. We have silicon providers on the left-hand side here, providing chips to provisioning centers. We have the hardware and software development engineers who are delivering out their respective deliverables. Typically, these will go into a programming center where individual chips will be programmed up with the target application and all the security information that we've been talking about. And that then will go on to contract manufacturer. And at the final day, everything else goes out to the end user, of course, in terms of the completed product. And you can see here how many actors there are in the process. Perhaps yours is a little bit simpler or perhaps even more complex than this. But at every stage, we have actors within those organizations who are potential risks to us. And also we have transfers of information between the organizations that are also suspect and susceptible to attack, and we need to protect those as well. And there's kind of a world map in the background there, so you can see that often these people are, of course, distributed globally. Design center might be in the US, manufacturing might be, or integration might be done in Europe, and manufacturing might be done in the Far East. So we have a very complicated supply chain here as we go up the volume ramp. So if you want a little bit more detail about how we've decided to go about addressing this problem, please search for IAR security from inception to take another look at the system in more detail. And really that's everything I wanted to cover today. If you've got any particular questions, I'd be happy to take them now. And I believe that there'll be a follow-up on-demand versions of this presentation, and you'll be able to submit additional questions at that time, which we will get back to you and try to answer your concerns and your queries, really. So it just remains to me to thank you very much for listening. I hope you've enjoyed this and found this useful, and hope you have a good day. Thank you.